Welcome back to the Scotti-BYTE channel, and this is Scott. So if you watched the channel for very long, or even if you haven't, you notice that one of the things that I like to focus on is infrastructure. And infrastructure is the foundation by which we build everything in the home lab. So you can't just jump right in and host an application, but you have to understand what you're building that upon. So with that in mind, today I want to talk a little bit about an issue that I ran into on my UDM Pro with its SFP Plus port and a WAN connection. So the UDM Pro port 9 is a gigabit port, and that is usually the default port for WAN communication to your ISP. But my Xfinity Comcast service is 2 gigabits down and 350 megabits up. And so that exceeds the 1 gigabit bandwidth of the 1 gigabit NIC that is on port 9. So therefore, I had to come up with an alternative, and that required using the UDM Pro's port 10, which is an SFP Plus port for my WAN connection. And that's certainly where you want to go if you're dealing with that. If you have, say, a UDM Pro Max, then that port 9 happens to already be a 2.5 gigabit port. But in any case, your SFP ports are generally 10 gigs. So I've tested and used many SFP Plus to RJ45 copper modules to make the port 10 to cable modem connection. And so these include the WiTech, the 10G Tech, the high fiber, the UDM, and the MikroTik. So I have used a wide variety of these RJ45 SFP Plus modules. And all of these modules are speed adjustable on the SFP side, and they're also speed adjustable on the Ethernet side, although that's not immediately apparent. So what problem did I run into? Well, the SFP Plus to RJ45 copper modules are well known to run very hot and can fail or lock up. And initially, when I had one of these modules, and I can't remember which one was my first, it ran great for a couple of months, and then eventually I started to have an increased number of lockups. I started to research it, ask ChatGPT some questions, floated around the internet and looked at different forums, and everybody reported about the same thing, which was, gee, SFP connections are pretty much great if you're going from a fiber module to a fiber module. But if you start using an SFP plus RJ45 copper module, then you can have a number of problems, most of which are related to heat. I didn't understand the heat thing totally until I tried to pull one of my SFP Plus copper modules out of my UDM Pro one day, or I think actually it wasn't on the UDM Pro. It was one connected to one of my 10 gigabit hosts. And when I did so and reached down, I about took my fingerprints off, because those things, you need an oven mitt to pull them out. And I'm not kidding. So WAN data burst that modems frequently experience can cause a cable modem to retrain, in other words, readjust its speed or reset its speed, thus reinitializing and auto-negotiating the Ethernet side of the link between the modem, which would be the 2.5 gigabit link, and the SFP Plus module. So it seems like once you go from a cable modem that's DOCSIS 3.0, almost all of those are gigabit connections. And when you go to the DOCSIS 3.1 modems, you'll find that they generally have a 2.5 gigabit connection. So recent versions of Unified Network, and I'd say version 10 plus, but you know, it might have started a little bit earlier than that. They no longer allow changing the SFP Plus module speeds. And if you look at your switches and you look at your SFP ports, you'll see that they're set to auto-negotiate, and there's no longer an option to make a change to that or set a specific speed. So these result in ISP connectivity failures, yet the modem status is absolutely fine, and kind of the way around it is to cycle power on your modem. So let's talk about some of the solutions. Well, the MikroTik S Plus RJ10, and yes, that's actually a model number, that particular SFP Plus to RJ45 copper module is definitely the most resilient of the ones that I've tried out to those particular issues, because its firmware tends not to auto-negotiate the Ethernet side of the link, and so therefore it generally doesn't cause those modem problems. That being said, it does eventually cause the same problems. And whether they're heat related or whether they're speed related, I'm not entirely sure, but I can guarantee that you will have a network issue on your connectivity to your ISP. So the MikroTik just fails less often than the others. And so to me, failing less often isn't as good as failing never. So this problem exists on connecting host with SFP Plus to RJ45 copper modules also, and I've actually had the NIC freeze up on a machine where, say, the host machine had an RJ45 connector that was 10 gig, but then I was going to a switch port that was an SFP Plus switch port, and I put one of these RJ45 SFP Plus modules in it. So I had very similar kinds of lockup situations with that. So I solved this with the use of a Ubiquiti USW Flex 2.5 gig 8 switch, and the 8 kind of means that it has 8, I suppose, regular 2.5 gig ports, and then it has a 10 gig port and a SFP Plus module port. So I connected the Flex switch to the UDM Pro port 10 via fiber. So I could go from the fiber on the USW Flex over to the fiber on the UDM port 10 using fiber SFP Plus modules on both sides. And so I connected the Flex switch to the cable modem via one of its 2.5 gigabit ports also. And if this is confusing, we're going to draw some pictures because I'm a little bit more visual myself. So the physical configuration looks a little bit like this. I have a Netgear Nighthawk CM3000, which is a DOCSIS 3.1 modem. And on that DOCSIS 3.1 modem, it has that 2.5 gigabit connection. And so I connected it to port 1 of the USW Flex 2.5 gig switch. And then I have an SFP Plus module, that's a fiber module in this switch, which goes to an SFP Plus fiber module in port 10 of the UDM Pro. So effectively, this is my WAN connection here. And then I have another connection, which we're going to talk about in depth in general. And basically what it does is it goes around the UDM Pro and goes directly to what I define as my top level or my core switch 1 in my configuration. And it's a USW Enterprise 24 PoE. So here's what it looks like. We've got a 2.5 gigabit circuit going from the modem to the Flex switch. And we have a 2.5 gigabit connection going from the Flex switch down to one of the ports on the switch that is inside the network, the enterprise switch here. And then we have a 10 gig connection that is going from the switch, the Flex switch, down to port 10 of the UDM Pro. So how exactly does this work? Well, obviously we've got our ISP connection here at the modem, and it's going to port 1. And then we have our WAN connection going down to UDM Pro, and the UDM Pro is using that port 10. And then we had this third red line here in the middle, and basically what that's doing is it is performing what I call unify switch management. And we'll get into that a little bit more here in a second, but basically what's happening is that allows me to adopt and also to manage that switch and to do settings and look at statistics on that switch. And then obviously the other port, which I believe is port 11 on the UDM Pro, is another SFP Plus port, and it's going fiber module to fiber module also, and that's going down to the what I call my core switch 1 that's right underneath it. So I look at this as being inside my network, and this switch here is actually outside my network. And to illustrate that, we're going to say, well, we got a cable modem up here, and then I'm going to say I have an edge switch here. So this edge switch is theoretically outside of my LAN because it's on the other side of my UDM Pro. And so being up here makes it an edge switch. It makes it outside of the LAN. And then inside the LAN, of course, is core switch 1, and then several switches beneath it are also inside the LAN. So here's what my unified network looks like. And I've highlighted the UDM Pro here, which is Scott and Cat. And I've highlighted core switch number 1, which is that enterprise switch there. And it's got that SFP Plus port going on there. And I've also highlighted the edge switch. And you'll notice that it has a LAN address also. I've given all of my switches addresses in 172.16.10, which is part of my main LAN address range. And so all these switches are on that. So from the perspective of this display, it looks a lot like the flex switch is really inside the network. But it's really only inside the network logically, because physically, as you saw from the diagram, it is outside the network. So how exactly can this work? Well, the flex switch port 8 to the USW Enterprise port 17 is for adoption and management only. So you got to remember that a switch, really any kind of switch, is also a bridge, and it's also technically a repeater, which means that anything that has IPv4 traffic is broadcast based. So that means anything broadcast on port 1 also goes to ports 2 through 8, 10, and 11 for that matter. So therefore, everything hears the traffic from everything else. But you also have to realize that it's isolated in network subnets. That is, unless it specifically has a gateway that allows it to get to another network, it cannot actually access another network. And that's really the case with this Flex port 8, because even though this Flex switch has an address inside my network, nothing that is above the UDM Pro understands that address range. And then this works because the Flex switch gets a DHCP address from the UDM Pro over that link, and I made it a DHCP address reservation. So it has an address within my main LAN, and my main LAN can talk to it in virtue of that connection. And then the address is a private NAT address. That address we saw earlier, 172.16.10.6, and therefore it's not routed over either the cable modem or to the WAN or over the Flex switch to port 10 to the UDM Pro. And I can manage the Flex switch as an edge device, and it removes the problem with flow control and unreliable SFP plus RJ45 copper modules. And that Flex switch is about $160 or $170 US. So it's a fairly cost-effective solution to solve the problem. I might point out that that last SFP plus copper module from MikroTik that I bought was like a $65 device, and I ended up returning it because I noticed it still had the same issue. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.